In our previous video, we implemented some IPv6 addresses on router interfaces. Now, what did that get us? Well, it got us some directly connected networks for IPv6 on the routers. So the routers have some routes in their routing table for those directly connected networks. It also sets up the foundation for us to implement static routing. Now, a couple questions I have for you. What's more important, putting in some commands correctly or putting in the correct commands correctly? And it really is important to have a plan in place when we're configuring and working with the network. We want to have an intention. What do we want to have happen? What are the commands to do it? And then how do we verify it? So in this video, what I'd like to do is we're going to take our topology that we just built in the previous video, and let's together talk about a plan of what we could do as far as static routes, because we can do network routes, we can do default routes, or a combination of those. So in our topology, let's make a plan of what we want to do, and then we'll follow it up with a lab where we'll implement those solutions and then verify that they actually work. So let me start the ball rolling with some options here. Option number one, which, by the way, is not going to be our best option, so we're going to hold out for more. Option number one, create static network routes for every single network. So we've got this network and this network and this network and this network, and then we need to identify where we need to create the routes. So R1 knows how to get to network 1 and 12. That means we'd have to create static routes on R1 to get to the 23 network and also the 3 network over here. And on R2 is directly connected to the 12 and 23, but it would need a static route to get to network 1 and also to get to network 3 because it's not directly connected to either of those. And then on R3, which is directly connected to network 23 and 3, we'd need a static route that says how do you get to 12 and how do you get to 1. So that's 6 static routes. And as much fun as that is to do, I mean, in IPv4, I walked you through it because I wanted just to have the experience and see and do it. But 6 static routes, that's, for this teeny little network, that's a lot. So what I thought is that's option number one. And everybody who wants to do option number one, you can do it, because in the lab environment, you can go ahead and do it any way you want to. So have at it. But it's not the most efficient because it's a lot of configuration. We have to touch all the devices multiple times with multiple routes. So what's another option? Another option would be a compromise. Let me take off those markings. So another option that I think would be a better one would be maybe from R1's perspective, anything that he is not locally connected to, 1 and 12, we could do a default route for IPv6 that says, hey, dear Mr. R1, you need to reach any IPv6 networks that aren't directly connected. Just give them to R2. He'll take over, or she'll take over, depending on the gender of the router. We could do that, and that would simplify, instead of having 2 static routes on R1, we just have 1. And then on R2, it's a bit tricky because R2 has network 1 that it needs training on. It also needs to learn how to route to network 3. So on R2, we could do 2 static routes, 1 to network 1 and 1 to network 3. And then on R3, this isn't like ideal, but it would work. We could go ahead and simply do another default route. We could say on R3, listen, if you need to forward IPv6 packets and you're not directly connected to the networks it needs to go to, maybe the server is responding back to Bob, which is over here on network 1, we could do a default route that says, hey, Mr. R3, you get an IPv6 packet, you're not sure what to do with it, we'll set you up a default route then and use R2 as the next hop for that. And that would do it. So I think this option here would give us an opportunity to do 2 traditional static routes on R2. It would give us a chance to do a default static route on R1 and a default static route on R3. So let me share with you the syntax of what that might look like, because we're going to do it here in the very next video. So as part of your journey through the world of CCNA, there's some opportunities to learn IPv6. And if you want even more exposure and details on mastering IPv6, there's another course here at CBT Nuggets where I just went a little crazy into the details of packet analysis and various options with IPv6. So as much IPv6 as you would like, we have more content here at CBT Nuggets. But for routing, I want to share with you and reinforce a couple of basic concepts about IPv6 and routing. And one of those is the default route. With IPv4, my question for you is, do you remember what the IPv4 default route looks like? And if you're thinking, yeah, it had a whole bunch of zeros in it, you're spot on. It's this: 0, 0, 0, 0, it's dotted decimal, space 0, 0, 0, 0, where the mask would go. And that's how we represent a default route. Basically saying, if you don't have a longer match in your routing table, this is your default last go-to ditch effort. Use this route if you don't have a better match in your routing table. Well, with IPv6, it's a lot of fun. With IPv6, it's this: colon, colon. Now, colon, colon, back to back means there's one or more sections of missing zeros. And in this case, everything's zeros. So colon, colon, and then to make it definitely clear, /0, that is the default route in IPv6. So if we are setting up an IPv6 static route using the default route, we'd say something like IPv6 route, and then these are my little spaces here, and then we do the default, which is colon, colon, all zeros with a 0 length mask, space, and then we specify the next hop that we want to use. So in the case of R3, that next hop would be R2's address of 2001 DB8678323.2. And I'll put hop there just to be clear. And that's how you set up a static default route. Now, if we were actually after a specific network, like R2 is going to need to learn how to get to the one network, we would say IPv6 route, and then we'd put in the network 2001 DB86783.1 colon colon /64, because that's the network we're trying to build a static route for, and then followed by the next hop. So on R2, that next hop would be R1's address of 2001 DB86783.12 colon colon 1 right there. So the great news is that the logic about the routing, the static routing, is very, very similar to IPv4, except the representation for the default route looks a little bit different, and there's a whole bunch more characters that we get to put in when we're statically configuring these routes, simply because IPv6 is 128 bits in length, much, much longer than IPv4, so there's more typing to do. So let's take this plan and let's implement this with the very next video in the hands-on lab, and we'll implement a default route on R1, static network routes on R2, and a default route on R3, and then we can test end-to-end connectivity with IPv6 static routes. So I'll see you in that next video. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.